This is Sparks Sustainability, and I'm Eric Sparks. Okay, so we want to move towards a circular economy, and the building and construction industry account for at least 37% of all greenhouse gas emissions around the globe, half of all waste that goes into landfills, and 40% of the contamination of drinking water. How in the world can we start to make this industry circular? Could we really reuse materials in construction? An architect or engineer draws up plans for the structure. Then they choose the materials. The contractor puts in bids, and once the contractor wins, they start ordering those materials. How can anything circular even be done in there? If it's a building, the architect is going to choose newer modern materials for both the structural elements and the ornamental and functional elements. Buildings can be deconstructed and their materials made available. But how can those materials ever be used in a new building unless the architect somehow magically knows that those exact materials will be available months or years in advance and decides to choose those exact materials? If those aren't the exact materials that he chooses, then they simply won't be used under the current model of building and construction. Of course, the deconstructed materials can be recycled, but that process takes a lot more energy and time and generates a lot more carbon emissions. How could the materials be used as is, or with just some refurbishment? I started wondering how this could be changed. How could we change the model or process so that we could reuse materials? Even if an architect and their client want to use circular materials in their construction, how could they know what circular materials will be available months or years from now when construction starts on this project? I was thinking about that, and it seems to me that what might be needed is a modification of our current methods or standards of doing architecture. Currently, they specify an exact material with exact dimensions. What if they didn't specify the exact material nor the exact dimensions? What if, instead, they give a range of properties and sizes that the materials need to fit within? The steel beam, for example, needs to have this much tensile strength, or load-bearing capacity, or compressibility. The wood paneling needs to be between 3 millimeters and 10 millimeters thick, be this many centimeters tall, and be this general shade of wood. If the architect were just giving ranges, then when the builder is ordering materials, they could make use of whatever materials will be available at that time. Now, obviously, if it is an extreme structure, such as a skyscraper, it may not be possible to reuse materials that are necessary for the structural stability. But for the ornamental and functional elements, and other non-extreme buildings, it would still be possible to use circular materials. Also, if the structural elements in the skyscrapers are steel beams, then they could still be made from recycled steel. Admittedly, this would greatly complicate the process of purchasing materials. Rather than simply finding exact materials and ordering them, purchasers for the contractor would likely need to work with the architect when selecting materials, especially structural ones, and even with the client when selecting ornamental materials. If a building is large, it may be difficult to get suitable ornamental materials in sufficient quantities for the entire building. It might become a trend to style different floors or sections of a building differently. With a 10-story building, maybe the first 5 floors are in one style and the next are in another. Or maybe every 2 floors have a different style. Or maybe every floor has a different style. When the contractors submit their bids, they might submit a minimum amount of circular material that they guarantee to use in this project, along with an amount that they think they will be able to use but aren't held to. Perhaps it could even become common practice to submit multiple bids with multiple different levels of guaranteed circular materials. The circular materials commodities market I mentioned in an earlier episode would help greatly with purchasing, since circular materials could be searched for by their properties and location. Go take a listen to that episode if you haven't yet. Another thing that I mentioned was the usefulness of a large construction firm having their own deconstruction division. Being in control of many different projects could aid in scheduling, and the deconstruction division could be one of the primary material suppliers of the construction division. As the deconstruction of large buildings would involve many different types of materials, many of those materials will need differing levels of processing. Some materials might need remediation to remove hazardous materials. Some materials might need refurbishment if they are largely fit for reuse but simply need some cosmetic touch-ups. Other materials, even too damaged for refurbishment, would need to be recycled, like perhaps concrete or scrap steel or other materials. These recycled materials might flow back into items manufactured for the construction industry, or they might flow into various other industries wherever there's a need for them. Deconstruction isn't widespread yet, and so the use of circular materials may or may not represent a significant financial savings when purchasing them. Any new materials and processes are generally more expensive until they reach mass production scales and the efficiencies those bring. Eventually, when deconstruction, rather than demolition, becomes the norm and processes, tools, and methods have matured, I suspect that there will be significant financial savings. Until then, there will likely need to be some tax incentives, subsidies, grants, or other financial incentives to jumpstart this reuse of materials. Ideally, there would be incentives for the architects, the contractors, and the clients. The larger the amount or percentage of circular materials used in the construction of this structure, the larger the financial incentive. Now, clearly this would be a significant undertaking. Setting aside the availability of circular materials from how little deconstruction is currently done, we are still left with the large task of revamping our current architectural models, processes, and sets of standards. Calling out a range of properties that materials need to fit within is very different than finding and specifying exact materials. How would that even look on the CAD drawings? How would it work in practice? How would design standards have to change to accommodate this kind of model? Even the codes and permits departments of a city would need to work differently to be able to approve plans that don't call out specific materials, but simply a range of properties. Just to get these changes to the architecture standards would be a lot of difficult work, but it would be worth it because it would be the first step towards a circular construction industry, a big step towards lessening the amount of waste going into landfills, lessening the emissions that come from the manufacturing of new materials, and in lowering the amount of contamination that is happening to water supplies. I think it's an interesting idea, and the more I think about it, the more I think that something like this is going to have to happen in order for the construction industry to become circular. Exactly what would the changes look like and how hard would it be? We won't know that until someone in the industry starts looking at it and gives it a try. Thanks for listening. I'm Eric Sparks. For more info or to contact me or for a text version of this article, visit sparksustainability.com.